Number 80. Which compound in each of the following pairs has the larger lattice energy? And then note, Mg2 plus and Li plus have similar radii, and O2 minus and F minus also have similar radii, and then we have to explain our choices. Okay, so we have lithium selenide, which is Li2Se, and magnesium oxide, MgO. Which one of these has the larger lattice energy? So which one of these has or requires a larger amount of energy to break these ionic compounds into their ions? So, in order to figure this out, let's just first write out what the ions are when these ionic compounds break down. So we have lithium and selenium. So this will break into Li and Se. Now on the periodic table, lithium is a +1, right? It's in group 1. And selenium, it's in oxygen's group. That's group 6A, 16. So that's a -2. MgO, this breaks down into magnesium and oxygen. Magnesium is in group 2, so that's a +2. And selenium is the same group as oxygen, just like we said, so that's a -2. Okay, so now, which one of these has the larger lattice energy? Well, lattice energy depends on basically two properties. The increase in the amount of electrons that are transferred from the metal to the nonmetal, because these are ionic compounds, will increase the lattice energy. So 2 electrons will have a larger lattice energy than if you were transferring 1 electron. And the other property is atomic radius. The smaller the atomic radius of your atoms or your ions will increase your lattice energy, because the smaller you are, the closer you're gonna be. And if you're closer, you got a strong attraction, and that's gonna, take a lot more energy to break up the bond. Now they did say here that magnesium 2 plus and lithium 2 plus 1 have similar radii. So between this lithium and this magnesium, they have similar radii. So I can't really make any, assumptions about these in order of increasing or decreasing lattice energy. Now let's see what the atomic radius would be for selenium and oxygen. Now this is going by our atomic radius trend, which is this right here. Let's just pull it down a little bit. So our atomic radius trend always decreases as you go across a period, but it increases as you go top to bottom. So let's find out where these two atoms are on the periodic table, selenium and oxygen. Now on the periodic table, oxygen is on the top and selenium is on the bottom. As you're going down, you are increasing in your radius, which means that oxygen is going to be smaller and selenium is going to be larger. Well, in this case, the smaller the atomic radius, the higher the lattice energy. The oxygen and the magnesium are going to be closer together than the lithium and the selenium. So since oxygen is smaller, this has a lower atomic radius. We now know that the MgO would have the larger lattice energy because oxygen is smaller than selenium. Smaller the radius, more attraction, harder it is to break up that ionic compound. And that's it. I hope this helped. Thank you for tuning in. Let me know in the comments, subscribe to the channel, and I look forward to helping you in future problems. Take care of yourself, and I'll be talking to you soon. Okay, toodaloo. Bye-bye.